All right, we're going to continue with our test for anions, how to identify various anions. Those are acidic radicals. So we have talked about SO4, how to identify SO4. That a preview, like I said earlier on. We run it with barium chloride, we get a white precipitate, which is insoluble. Then we have SO4 in inference, SO4, CO3, S2 minus, CO, and so on. Those ones are present. Then when we run that with HCl, the white precipitate is insoluble in SSHCl. That we confirm that is SO4. But in the case of SO3, the white precipitate is soluble in SSHCl. Then we have CO3 and SO3 probably present. And we have to proceed further by adding drops of dilute H2SO4, yes, followed by KMnO4, where the observation, the purple color of KMnO4 is decolorized, and that confirms what? Our SO3. Then in the test for NO3, triazonitrate ion, in the test for it, we have freshly prepared, to the sample, we have freshly prepared ion 2 tetrazosulfate 6 in it. We say the reason why we deal with freshly prepared is because if you prepare ion 2 tetrazosulfate 6 and keep it, to decolorize or oxidize into what? Ion 3. So because of that, we prepare freshly and we use it. So after preparing freshly prepared ion 2 tetrazosulfate 6 acid, we add it to the sample, and that followed with we slant the test tube and add what? Concentrated H2SO4 to the side or the walls of the test tube, and we don't allow it to mix. After that, the observation, we say a brown ring is formed at the interface between the two solutions, and that confirms that it is NO3 present. So we're going to proceed with other anions. So example, we're going to run today Cl, chloride anion, bromine, iodine, and so on. So let's see what we get when we run all of these. And we're obviously going to cover all of them. It is our duty to ensure that all of these test, observation, and inferences of these various anions are in our head. By that alone, we'll be able to proceed to do our practicals without having challenges. If you don't know what you're going to get in terms of observation or your inference, and you are carrying out a practical, you have white precipitate, what then do you say will be your inference if you don't know that white precipitate should be CO3 or SO3 or SO4? And if the precipitate is soluble or insoluble, you will know that if it is insoluble, it is SO4, if it is insoluble, it's CO3. So you must put them in your head and take note of that. So I'm going to write this out, then explain them religiously. By so doing, we'll move in one piece. All right. So this is test for chloride anion. So these are the procedures, the test, observation, and inference. We have a sample that contains chlorine, let's say sodium chloride. We want to test for the anion. When we precipitate it, add water, a little water in it, the compound is meant to dissociate into its ions, sodium plus and chlorine negative. When we add to that solution, when we add silver nitrate, the silver nitrate as a reagent will react with the chloride anion, not with that of sodium. So when it reacts, it will give us white precipitate will be formed. So when you see white precipitate, what are the probably inferences or other ions that could give us white? We have the chlorine anion, the sulfide, and SO3. All these guys give us white precipitate. We say they are probably present, but we don't know which one. So we have to proceed further to carry more tests in order to isolate, to know the one we're dealing with. So having gotten that, now we don't know which one here is the main stuff we're looking for. So we have to proceed, since we're testing for the chloride, we have to proceed to add dilute HNO3. Dilute triazonitrate acid will be added to that solution above. When we do that, the white precipitate is insoluble in excess of dilute HNO3. Now it is insoluble in excess. We now proceed to say, okay, chlorine confirmed, because only chlorine is insoluble in excess of this. Now that is not all. We still proceed to the solution above. We add ammonia solution to it. when you add ammonia solution, the precipitate now dissolves. So ammonia will now dissolve it. Remember here, it is insoluble in essence, and we have chlorine there. But once we add ammonia solution, this white precipitate will now what? Dissolve. And when it dissolves, we say chlorine is further what? Confirmed. So that is the confirmatory test for what? Chlorine. So what happened? To the first one, we say you should know sample A plus was silver nitrate. You have what? White precipitate is formed. These are the inferences: chlorine, anion, S2 minus, SO3. That is not all. We add HNO3. The white precipitate insoluble in excess of HNO3. Chlorine present. Then we proceed further by adding what? Ammonia solution. We will add ammonia solution. The so insoluble whatever becomes what? Soluble. And that we say chlorine is confirmed. Then this is for chlorine test. So we have to do the same thing for bromine, iodine. Let's see the difference between the halogens. So I move further to the other one. Now for the bromide anion, we have to the solution we add silver nitrate like we did in that of chlorine. We have cream or pale yellow precipitate is formed. The other one for chlorine was white precipitate was formed. Bromine is probably present. The other one was chlorine, S2 minus, SO3 probably present. Now we move further, we add the same reagent to, we now add to the precipitate above, we add triazonitrify acid solution. The precipitate is insoluble in excess of HNO3. Alright, the chlorine too was also insoluble, yes. There is the bromide anion present. The other one was chlorine, confirmed. So now, to the precipitate above, we add ammonia solution. We have the pale yellow precipitate becomes partially soluble. Chlorine, in that of chlorine was soluble. The bromine is partially soluble. So we say bromine confirmed. So in the test, if I probably want to ask you questions about the halogens, I can say to sample A, add silver nitrate. You have observation here. I will not put the observation. I'll tell you bromine is probably present. Then you will know that cream or pale yellow precipitate is formed. That is the color for bromine. White chlorine is white precipitate is formed. Then we will see that of iodine. I think iodine is just yellow, and so on. You should know the color differences, the observations, and the inferences of what you should be expecting in this situation. So when we are running the practical majorly, you will know, since you understand the basic principles, you now know when you have white or cream yellow precipitate, you now know what is your observation, what you should write as observation, and what you should write as your inference. And by so doing, you will know exactly what you're looking for. So let's deal with that of iodine and see. Alright, for the iodide ion, we say to the solution, we should add silver nitrate. We have a yellow precipitate is formed. Iodine is probably present. To the solution above, or to the precipitate above, we should add HNO3 triazonitrify aqueous triazonitrify acid. The precipitate is insoluble. Iodine is probably present, or iodide ion is probably present. To the precipitate above, which is that, we should add aqueous NH3. The yellow precipitate is insoluble in excess of ammonia solution. Iodine is confirmed. So we have been able to look at the test, observation, and inference of chlorine, iodine, and bromine so far. We say in that of chlorine, when we added silver nitrate, we have a white precipitate. We have chlorine, SO3, S2 minus, probably present. And in that of bromine, we have cream or pale yellow precipitate formed, and we have bromine probably present too. When we added the HNO3 triazonitrify acid, in that of the chlorine, the white precipitate is insoluble. In the other one, the white precipitate is insoluble. In bromine, the pale yellow precipitate is insoluble. Now in iodine, the yellow precipitate or the precipitate is what? Insoluble. In the other way, we have chlorine, confirmed, bromine, present, iodine is probably present. And the last step to the precipitate above, we add aqueous ammonia, NH3, NH4OH, aqueous ammonia, that's ammonia in water. The yellow precipitate here is insoluble in excess of ammonia solution. In bromine, the yellow precipitate is partially soluble. In chlorine, the white precipitate is soluble. So here, iodine confirmed, bromine confirmed, chlorine confirmed. So this is what you should know. It should be in your head. If I ask you to test for chlorine, for example, you should know to the sample, add silver nitrate, you get white precipitate, chlorine present or chlorine present, S2 minus present or SO3 probably what? Present. You come down to aqueous HNO3, the white precipitate is insoluble in excess of what? HNO3 triazonitrile 5 acid solution, then chlorine confirmed. And the last one, when you add aqueous ammonia, the white precipitate is soluble, chlorine further confirmed. You should know these things that should be in your head. If I ask you for bromine, you should just break it down for me. If I ask you for iodine, you break it down for me. If you understand them now, when we are running our practical, you will not be lost. Well, once you're getting your observations and your inferences, you know exactly what you're looking for. It makes the work easier. So we're going to proceed further to test for other word anions. Okay. Let's test for triazocarbonate 4 ions. Alright, for the CO3 2 minus, we say to the solution, you should add dilute HCl or HNO3 and test the gas evolve with lime water. There is evolution of CO2 which turns lime water milky, is our observation. So we have CO3 or HCO3 present. This is normal sense, common sense. We know that when we react HCl this with a carbonate, you must get a CO2. Let's take, for example, let's say calcium triazocarbonate 4 plus HCl. This will give us calcium chloride plus water, H2O plus CO2. If you balance it, we have one calcium, we have chlorine 1. We have 2 hydrogen here, 2 hydrogen there, 1 here, so I have my 2 here. Hydrogen is 2, chlorine is now 2. I have CO2, I have H2O. Okay, now 2 hydrogen, oxygen, 1 plus 2, 3, calcium is 1. I think we are good. Yeah. So by so doing, you know that when you react a carbonate with any acid, it must give you a CO2. The gas will be evolved. So this, I can put it this way, or I put it this way, anyone. This is liquid, this is aqueous, this is aqueous, and this is aqueous. So, in that sense, when that happens, that is what you get. So we know too well that they say to the solution, add dilute HCl or HNO3 and test the gas evolve with lime water. We know that CO2 always turns lime water milky. But once you've heard with lime water, your mind should go straight to know that it is CO2 gas you want to test, because it is CO2 gas we always test with lime water. And that CO2 will turn lime water milky. And having said that we are reacting with that sample, we don't know what the sample or the solution was, but we are reacting with HNO3 or this, we should know that it is a carbonate, which means this will come. So having conceived in your mind that it is a carbonate, it could be hydrogen triazocarbonate 4 or calcium triazocarbonate 4, whatever it is. Now we know the inference. From that inspection alone, we'll be able to tell that it's either CO3 2 minus or HCO3 present. Now that is not all. Now to the solution, which is this above, we should add 2 drops of phenolphthalein. When we add phenolphthalein, a pink coloration is formed. That confirms this guy. It confirms what? That it is CO32 minus. Because it is in the presence of CO32 minus that we can only get what? A pink coloration. So that is the test, observation, and inference for a CO3 or carbonate ion. So take note of that and know the difference when we're dealing with it. Okay, which one again do we deal with here? Okay. Let me see. We've dealt with SO3, SO4, SO3, NO3. Okay, that's not bad. CLB. Okay, let's deal with S2 minus. Precipitates. We just make this now. All right. Here, to the solution, add silver triazonitrate 5 solution in drops and then in SS. When you see black precipitate form, you know that it's S2 minus confirmed. So that one, we don't stress ourselves, we don't do much. So I think we are left with just one more to round up on test for anions. Okay, so we can call it off there. So that's that about that. That's where we stop about tests for anions. We'll proceed to carry out we'll move down to organic qualitative analysis. But for this, have a nice day.